Hello students, welcome to this video on Fractions Supernote Part 1. Make sure you're completing the note while you are watching this video. Let's start with Section A, Equivalent Fractions. Now when we're asked to make equivalent fractions, we can use one of two strategies. We can use multiplication or we can use division. Now let's look at example 1. Example 1, the numerator and the denominator numbers are fairly large numbers. So when the numerator and the denominator are fairly large, we should try division first. All right, so let's use our divisibility rules. We have a numerator of 50 and a denominator of 100. They are both even numbers. Now when both numbers are even, we know that they can be divisible by 2. So let's start with dividing by 2. So let's show our work here, and that we're going to divide the numerator and the denominator by 2. So if you can work that out, so 50 divided by 2 is 25, and 100 divided by 2 is 50. Okay, so we have one example of an equivalent fraction. 50 over 100 equals 25 over 50. All right, well, let's come up with a few more. So again, let's look at our original fraction, 50 over 100. And let's use our divisibility rules to come up with some factors for both the numerator and the denominator. So because both the numerator and the denominator end with the number 0, we know that both the numerator and the denominator should be divisible by 5. So let's try that. Remember, show your work. Show me what you're dividing both the numerator and the denominator by. Remembering the rule that what we do to the numerator, we also have to do to the denominator. So 50 divided by 5 is 10. And 100 divided by 5 is 20. So we have another example of an equivalent fraction to 50 over 100. Let's come up with one more. So again, using our divisibility rules, we know that 50 ends in 0, 100 ends in 0. So a perfect candidate for a factor would be 10. So let's show dividing the numerator and denominator by 10. So when we divide the numerator and denominator by 10, hopefully you came up with 5 over 10. Now, there's an obvious one that we didn't even touch upon. Let's do one more just for this case. What if we divide the top, the numerator, and the denominator by 50? Hopefully you got 1 over 2. Okay, so by dividing by 4 different factors, for this example, we came up with 4 equivalent fractions to 50 over 100. All right, let's go on to example 2. Example 2, 4 over 9. Now in this example, the numerator and the denominator numbers are fairly small. So it's going to be challenging to use division. In fact, it's impossible to use division to come up with an equivalent fraction. So let's use the opposite operation and let's use multiplication. Now when we multiply, you can choose any number and choose numbers that you can do in your head. So for our first example, easiest factor to multiply by is 2. So let's show your work and then please write in the equivalent fraction. All right, so hopefully you got 8 for the numerator and 18 for the denominator. Okay, so what other numbers can we multiply the numerator and denominator by? Well, you can choose anything, but I'm going to choose something easy that I'm going to be able to do in my head. What if I multiply the numerator and the denominator by 10? So please work this out. So hopefully you came up with 40 for the numerator. 4 times 10 is 40. And for the denominator, we have 9 times 10, which is 90. All right, let's look at one more example. So what if we multiply the top and the bottom, the numerator and the denominator, by 5? So please work out the equivalent fraction. So 4 times 5 is 20. 9 times 5 is 45. Okay, so by using multiplication, we've quickly come up with 3 examples of equivalent fractions to the fraction 4 over 9. All right, let's look at example 3. So this time for my first example, I'm going to start with a different factor, a number I haven't used yet. So what if I multiply the top and the bottom by 3? Well, we should get an equivalent fraction of 6 over 15. All right, let's choose another number that we haven't used so far. So what if I multiply the numerator and the denominator by 100? So 2 times 100 is 200. 5 times 100 is 500. And how about one more number that we haven't multiplied by? So what about 4? Multiply the top, the numerator, and the denominator by 4. And we should get 8 over 20. All right, so we've come up with 3 different equivalent fractions to 2 over 5. Okay, let's go on to section B, fractions in lowest terms. Now, when we're asked to reduce a fraction or simplify a fraction to lowest terms, we always have to be thinking about division. So it's very similar to the question that we did in section A, question 1. So we have to think about a number that can divide evenly into both the numerator and the denominator. And we have to keep going until we can no longer find any numbers that divide into the numerator and the denominator. So if we use our divisibility rules, we see that the numerator ends in 5 and the denominator ends in 0. So a good place to start is if we divide the top and the bottom by 5. So let's try this. So what's 75 divided by 5? Well, it's nice to have a calculator handy. 75 divided by 5 is 15. Now what's the new denominator going to be? 100 divided by 5 is 20. All right, now before we think we're done, we always have to ask ourselves about the new fraction. Can this be reduced even further? So in other words, can we find another number that can divide evenly into the top and the bottom? Well, the numerator ends in 5 and the denominator ends in 0 again. So we know that we can divide again by 5. So I'd like you to work out the new fraction. 15 divided by 5 is 3. 20 divided by 5 is 4. We have to ask ourselves, is there any number that can divide evenly into the top and the bottom other than 1? And the answer is no. And if the answer is no, then that means this is the fraction in its lowest terms. Okay, I'm just going to highlight this here, lowest terms. All right. So some of you might be thinking, well, Mr. Witt, I have a different way. I have another way that's even faster. Okay, so let's examine that strategy. So I'm going to rewrite the question here, 75 over 100. So when you're asking yourself, well, what number divides into both the top and the bottom, try to think of larger numbers. So if you think of 75 over 100 in terms of money, 75 over 100, 75 cents, and you got to think of 75 cents and a dollar in terms of quarters. So let's see, oops, sorry about that. Let's see if we can divide the top and the bottom by quarters. So divide by 25. Okay, I'd like you to take a couple seconds to work this out. 75 divided by 25 is 3. 100 divided by 25 is 4. Okay, so let's look at our two answers. We got the same answer, a fraction in its lowest terms, but in two different ways. And here are the different ways. In the first method, we divided by 5 one time, and then we divided by 5 a second time. So we took 2 steps. But in the second method, we only divided by 25. We only took 1 step. So let's take a look at the relationship between this factor, 25, and these factors here, 5 and 5. Do you see a relationship? Well, 5 times 5 is 25. That's why in method 1 we used 2 steps. We divided by 5 first, and then we divided by 5 again. But in method 2, we just divided by 25 in one step. Because when you're dividing by 25, you're actually first dividing by 5 and then by 5 again. So this is where it comes an advantage of finding a larger factor to divide into the top and the bottom. Okay, let's go on to example 2. 27 over 108. So we can't use the divisibility rules of 2 because the numerator is not an even number. We can't use the 5 divisibility rule. We can't use the 10 divisibility rule. But how about 3? Now again, here's where having a calculator is really helpful because you can just quickly check. I know that 27 is divisible by 3, and I've got my calculator here. So how about 108 divided by 3? And yes, it does come out to be a whole number. So 3 is definitely going to be a factor. So make sure you show me your work. Tell me what you're dividing it by. All right, if you can work this out using your calculator. So 27 divided by 3 is 9. And if you got your calculator handy, 108 divided by 3 is 36. Okay, now before we leave this question and before we move on, we have to ask ourselves, is there any number that can divide evenly into both the top and the bottom? Well, how about 3? So let's divide the top and the bottom by 3. So please work this out. Well, 9 divided by 3 is 3. 36 divided by 3, using my calculator, is 12. Are we done yet? Is there a number that can divide into both the numerator and the denominator? Yes. And that number is 3. So let's work this out. 3 divided by 3 is 1. 12 divided by 3 is 4. Now, can this fraction be reduced any further? No. As soon as you get a numerator of 1, that's all you can't go anymore. So in this example, we used 1 step, 2 step, 3 step. So I'm wondering if we could have made our life a little bit easier or if we could have come to an answer faster. So let's rewrite this. Let's have a look at if there are any other factors that we could have used. So I know that 27 is divisible by 9, but is 108 divisible by 9? And yes, it is. So how about we try dividing both the numerator and the denominator by 9? Okay, if you can work this out using your calculator. 27 divided by 9 is 3. 108 divided by 9 is 12. Okay. Can this fraction be reduced any further? Yes, it can, because it kind of looks like this fraction up here, doesn't it? So we know that the numerator and the denominator are divisible by 3. So 3 divided by 3 is 1. 12 divided by 3 is 4. These two fractions match. Now, is there a way that we could have come to the answer in one step? Well, let's use our other pen, our other marker here, and let's have a look at the numbers that we divided by. 3, and then 3, and then 3. So if I work this out up here, 3 times 3 times 3 is 27. So I'm wondering if that would be a factor here. Well, it's definitely going to work for the top, the numerator, and using my calculator here, I see that yes, it will work. So let's try dividing by 27. It's not very often that we get to use a factor of 27 for many numbers. So 27 divided by 27 is 1, and 108 divided by 27 is 4. So again, I just wanted to do 3 examples to show you that it doesn't matter how many steps you take as long as the n fraction is in its lowest terms or simplified form. All right, let's go on to example 3. 60 over 100. So divisibility rules by 10, right? So how about we try dividing the top and the bottom by 10? And I'd like you to work this out, please. All right, numerator 60 divided by 10 is 6. Denominator 100 divided by 10 is 10. But let's look at this fraction. Is it in its lowest terms? Well, it can't be because both the numerator and the denominator are even numbers. So we know that they can be divisible by 2. So why don't we divide by 2? And when we work this out, we should get 3 over 10 divided by 2 is 5. All right, so we used 2 steps here. I'm wondering if we could have done it in 1 step. Now, we could have taken a lot more steps if we had divided by 2 first and then divided by 2 again. But let's see if we can find a factor, okay, that would allow us to go straight to the lowest term in 1 step. Well, we divided by 10. I wonder if we can divide by 20. So I know that 60 divided by 20 works, and I know that 100 divided by 20 works. So let's try that. Let's use the factor of 20 for both the numerator and the denominator. So 60 divided by 20 is 3. 100 divided by 20 is 5. Okay, so again, we should always come up with the same number because it's the fraction in the lowest terms. We're starting with the same fraction. If I change colors, let's look at the first number we divided by, 10 and then 2. Well, 10 times 2 is 20. Here's why in our first method we used 2 steps And here's why in our method 2, in our second example, we only use one step. So this concludes the Fractions Supernote Part 1. So I'd like you to load up Part 2 now that you're done. Thanks.